Welcome to this explainer. Today, we're going to fundamentally shift how you look at safety, risk, and human performance in high-stakes environments. If you've ever wondered why highly trained, incredibly smart people make seemingly obvious mistakes, you are in the exact right place. Today, we're decoding the fascinating science of human factors. Okay, here's our roadmap. We're hitting the human error myth, defining the science, visualizing the system, the anatomy of an accident, and finally building a just culture. Let's dive right in. Section 1. The human error myth, blaming the individual. So think about this for a sec. When things go completely sideways, who gets the blame? Have you ever been blamed for a bad process or watched an operator take the fall for what was actually a system failure? It's deeply ingrained in human nature to want a culprit, right? We immediately want to point a finger at the person closest to the disaster. But as we're going to see, blaming the individual is almost always the absolute wrong approach if you actually want to fix the problem. Take a look at this powerful statement from the International Civil Aviation Organization. They totally challenge that knee-jerk reaction. They're telling us that the term human error is practically useless for preventing accidents. Because if you just shrug and say, well, somebody made a mistake, you're literally concealing the underlying organizational factors that guaranteed the mistake would happen in the first place. Human error shouldn't be the end of your investigation. It's exactly where you need to start pulling the thread. To put this into perspective, 3 out of every 4 aviation accidents come down to less than optimum performance by apparently healthy, properly certified individuals. Now, people aren't showing up to work trying to crash planes or ruin systems, right? So the real question we have to ask is, why did their performance break down at that specific moment? Moving on to Section 2, defining the science and really looking at human capabilities. Okay, so here's the core of it. Human factors is fundamentally about designing systems that support humans, rather than forcing humans to constantly compensate for bad design. It's this brilliant multidisciplinary science, pulling from psychology, engineering, and industrial design. It accepts a basic reality. Humans have natural limitations. We get tired, we get stressed out, we get distracted. So it says, let's design our tools and environments to actually account for that reality. To really grasp human performance, we have to talk about how teams construct a mental picture of their environment, especially when they need to recognize patterns quickly. Dr. Micah Ensley defines this as situational awareness and breaks it down into 3 levels. Level 1, just perceiving what's going on around you. Level 2, actually comprehending what that info means. And level 3, projecting what's going to happen next. Lose any one of these steps, and honestly, you are flying blind. But here's the catch. Our brains aren't supercomputers. We have a finite capacity. Under high stress, operators can literally lock on to a single, sometimes totally defective instrument and completely ignore other critical information. Why? Because as stress spikes, our attentional resources physically narrow. We might miss a flashing warning light right next to us. It's not negligence, folks, it's just biology. All right, Section 3, visualizing the system with the shell model. So, the shell model is a fantastic framework that breaks down exactly how we interact with our environment. Software here isn't just computer code. It's the documentation, the confusing procedures, the manuals. Hardware is the physical machinery. Environment is everything else, from blinding glare to high seas. And right there in the center, liveware. That's us, the human element. Human factors is the science of smoothing out the friction between that liveware and the other 3 pieces of the puzzle. When you compare focusing strictly on the individual versus looking at the collective system, something becomes really clear. If you only look at the front-end operator, management essentially gets a free pass. But if you scrutinize the system collectively, you start finding the real root causes. Exhausting schedules, poor training programs, confusing tech, things that practically set the operator up to fail from the get-go. Section 4, Anatomy of an Accident. Let's look at how systems actually fail. Accidents absolutely do not happen in a vacuum. Look at this chain of events. It maps everything from top-level decisions all the way down to the active error on the front lines. It starts with a fallible decision, maybe a budget cut in the boardroom. That creates a line management deficiency, like slashing the training budget. That creates a psychological precondition, meaning you now have an overworked, undertrained operator. And boom, that is what finally leads to the unsafe act on the floor. You've probably seen this brilliant visual before. It's James Reason's famous Swiss cheese model. It perfectly shows how latent failures align with a local unsafe act to break through system defenses. Every layer of defense in your organization, your rules, your alarms, your supervisors, is like a slice of cheese. But every slice has holes. An accident only happens when the holes in every single slice line up perfectly, letting a hazard pass straight through. Think of it like a giant iceberg. The active failure, like a pilot pushing the wrong button, that's just the visible tip. It is dwarfed by the massive invisible latent failures built right into the organization's design. The latent failure is the manufacturer putting two identical buttons right next to each other, and the airline deciding not to train the pilot on the difference. That's the real danger. Which brings us to Section 5, building a just culture and actually learning from our errors. We have got to transition away from the natural response of pointing fingers and focus on improving the actual systems our professionals use. Notice the old way. Blame rolls downhill on the person at the bottom just gets crushed. The new enlightened approach, it analyzes human cognition and applies it directly to equipment design and the work environment. It's a massive but totally necessary shift in mindset. Because here is the harsh reality. A culture of fear and punishment actually keeps systemic problems hidden, putting lives at risk. Whether you're in healthcare, aviation, or maritime ops, if people think they'll be fired for an honest mistake, they're going to hide their mistakes. They'll cover up close calls, and those latent flaws will just sit there in the dark, waiting to cause a disaster. We absolutely must build a learning culture where people feel safe reporting errors. So I'm going to leave you with a provocative thought to really challenge how you view your own workplace. Look around and ask yourself, are your systems designed for humans or against them? Are you setting your people up for success by accommodating their natural limitations, or are you just sitting back, waiting for the next inevitable error to happen? Getting a grip on human factors is the very first step toward genuine, lasting safety. Thanks so much for joining me for this explainer.